Static stability of floating bodies. So, a floating body is acted upon by two equal opposing forces. So, these are the body's weight. So, that will be the W. So, it is acting at its center of the gravity. We're assumingly we have here the center of the gravity of your object. So, for our representation only. So, might be here. So, we have your center of gravity CG here. So, we have also the buoyant force acting at the center of the gravity. So, that will be located at the center of the gravity of the displaced liquid. So, I'm gonna use a BO here. So, that represents the center of buoyancy in the upright position, the center of the displaced liquid. And I'm gonna use the BF, which means that will be the buoyant force. So represents as the buoyant force. Now, when these forces, your weight and your buoyant force, are collinear, so when the buoyant force are collinear, so they are in the same direction. Okay. So as was shown here in the figure, so the body floats in an upright position. Now, however, when the body tilts, let's say due to wind or wave action, the center of the buoyancy is shifted to a new position. Now, our buoyant force, that will be the or the center of buoyancy, so it is transferred to a new position. So as shown here, so from initial state without tilting, so we have here, then it is transferred to a new position, which is the BO prime. So we have the corresponding reaction of buoyant force acting here upward, and we have the corresponding distance here from the center of the gravity, which is the distance from center of gravity to the location of the new buoyant force. Location of the center of buoyant force, we have your BF. This will be the X. Okay. Then we have here the point here, we call the name letter M, call it M. So that is the meta center, or let's say the point of intersection between the line of action of the buoyant force and the axis of the body. Now you can see here that our buoyant force and the weight are no longer collinear. So the buoyant force was relocated to a new position, which is acting at the BO prime. So this produces a couple and equal to, which is the couple that will be the weight times the couple moment. So we have your weight multiplied by the x. Okay. So that is equal to the displaced one. So again, so we have a couple moment here. We have your weight and you have your distance, which is your x. So that is a couple. That is, you have a force here, then a force here acting. So you have a couple now. Now this body will not overturn. So if this couple makes the body rotate towards the original position, so if this couple, I'll try to rotate this one in this direction also. So if this couple try to return back to its original position, so the body will not we call that will not sink for now. The body will overturn if the situation changes to. So you will notice here we have already additional weight on the top of the ship, and the location of our metacenter is already below the platform of the ship, and the location of our center of the gravity is way above the metacenter, where at the center of the gravity, where our weight the line of action of the weight will pass through at the center of the gravity, which is already above the metacenter. Now, if you're going to examine the figure, so there will be an overturning moment occurring towards the at this side. So this one will overturn the ship and eventually will sink the ship. So we have an overturning since naglipat na yung location ng weight, or let's say the center of gravity already in different location. So we have an overturning moment, which is let's say this is OM, okay, overturning moment. So, or we have your couple. So usually ang couple natin supposed to be from previous, no? So we have here your couple here going back. So as the rushes of wave pushing here, no? So if you have your wave dito, push niya yung ship mo or tilting the ship, so you have an overturning moment. So you will notice here, no? We have your center of the gravity at this location, and you have your metacenter, which is above. Okay, so you have an moment that will overturn the ship or tilt the ship going back to its original position. While on this one, so we added the weight of the ship. We added cargo on the ship. Okay, so the location of our metacenter was already below sa platform ng ship. Okay, you will notice that one here. Then you will also notice that the center of gravity, which is above our metacenter, so this provides where the action of the line of action of the weight will be passing through. So this provides an overturning or tilting of the ship. So if there is a large wave splashing, or let's say splashing on this side, or tilting, okay, or tilting on this side, okay, if we have a wave tilting on this side or pushing the ship on this side, so eventually it will not overturn or go back to its original position, but eventually it will turn on this side and will eventually sink the ship or overturn the ship or tilt the ship. So that explains the stability of a ship, or let's say stability of the floating bodies. Okay. So we have here, so let's say this is yung overturning moment natin. So this will be RM. So let's say this is RM, and also the overturning moment here, which is your OM. Okay, so our RM or OM, that will be the writing moment or overturning moment. Okay, so our writing moment, that will be RM or OM. So that will be the equal to the moment of the weight times the X, this one. So it's the same also on this one. So we have your X multiplied by the weight. So we have your moment here, the overturning. Okay, so the couple on this figure. I will add um, representations of length here. So we have your MBO. So this represents the distance from M. So MBO is the distance from M to B to BO. So we have here from M to BO. So that will be the MBO. Then we have the GBO. So that is the distance from G to BO. So looking at one, we have from G. Okay, so this one from G to BO. The distance representing that one, and we have the MG, so that is the metacentric height. So the distance from M to G, look into the figure, so from M to G, so we have the MG representing the distance. Now to determine the metacentric height, so we have the equation here, your MG. Your mg, so your mg is equal to mbo, so that will be plus minus gbo. So looking at here, we have the mbo, m to bo, plus minus, okay, it depends, no, plus minus, it depends on the situation. So plus minus, we have G BO, okay, to determine the mg, which is your metacentric height. So metacentric height, again, looking back, that is the distance from M to G. Okay. So take note, use negative sign if the gravity is above the visible. So when the gravity is will be negative if G is above the visible. So we have your G, this one is where the G is above the visible, where our visible here. Comparing to this one, we have your G and your visible is in here. Okay, so that is positive. So that is in kabaliktaran ng kabila. So okay, now use positive if the G is so pag ang G is below the visible. Tulad ng nito. So if this is the situation, if G is so that so G, so going back again, so use if the G is above, or use negative if the G is above the visible. So it depends on the situation. Okay, so if G is positive, use positive if G is below the visible, so that is magkabaliktad naman sila. So mostly nangyayari where our G is above palagi. So looking at the situation, G is above the visible palagi. Okay. So even in the floating bodies here. Okay, so take note of that one. Okay. And take note also yung M natin, which is your metacenter, is always above the visible. So looking that in the figure, so M will always be above the visible palagi. Okay. So we have your M here and you have your visible here. And the same also here, we have your M and you have your visible. Okay, so take note that the stability of the body, so that depends on the amount of the writing moment. Okay. So which in turn is dependent on the metacentric height. We have here the metacentric height, so mostly will be depending on the writing moment on here of your metacentric height. Natin, statical. This one. Okay, so the distance. No? Take note of that one. So when the body tilts, okay, so you will observe that one. So when the body tilts, the center of buoyancy shifted to a new position, which is yung ating B sub O prime. Now, this shifting will cause a wedge B. So I'm gonna draw that one. So saan ba ito? Which is the wedge B prime. So this is the part which is yung sinasabi na wedge B prime. So we have here your volume that is originally from initially, so that is pantay siya dito sa ating bodies of water. Now, if the wave is acting on the shift, so we have a displacement of volume from here which is being shifted doon sa kabila at this side, where our new position, so which is transferred to this one, so we have here another volume that is being displaced, that is being transferred dito sa kabila. Okay. We have here another volume that is being transferred here, so I'm going to call it a B, and the other one is B prime. Then we have here a force acting, okay, so because of this weight, so we have also a force acting on this side, which is eventually have a corresponding a force that is also acting on opposite side. So this is the same distance also here is being nangyayari, no? So we have the same distance also from here. Then we have here a force that is being acted on this side, so we have your F also in reverse of that one, so yung counteract niya. Now so due to the moment of the shifting of the buoyant force, so we have here now the moment due to the shifting of the buoyant force, which is from B sub O buoyant force times the moment, which is the BF times the Z, so it must be equal to the new moment. It must be equal to the moment due to the wedge shift, which is from F, okay, from this one. So that will be, so ito yung magiging ano natin, so this will be your S. So yung nito, ang value ng moment ng B times yung BF times Z, so it must be equal to the moment of your F force times your S, which is the distance from this one. The moment due to the shifting of the BF, or the buoyant force, is equal to the moment due to the shifting of the wedge. So let's do that one. So we have now the BF multiplied by Z, so that is the moment nito. Then it's equal to the moment, which is your force times your S. So we have here, okay. Then we have the value of your buoyant force, which is equal to the specific weight. Okay. So the specific weight times the volume displaced, PD. Okay. There our force is equal to the specific weight of the fluid, then times we have the volume of the wedge, this one, okay. Then and for the distance of the say, so we will notice here we have a triangle dito, so we have formed a right triangle here, no, so we have your theta here and we have your say here, and so we have the distance dito, then we have the height, which is your sorry for we're going to relocate this line, so it will be somewhere here. So I'm relocating that one. So we have here, sorry, this is the distance with a BO, so that will be the Z, so that is from BO to Z. Now we have formed here a right triangle. You will notice that one, ito yon, okay, this side. So we have here your Z. So we have the line here which is MBO. So we have your line here which is M. So I'm going to draw this one, a bigger one. So we have here the line which is your MBO, and we have here your Z. Okay. So we have your theta here. So that will be, if you're going to remember triangle, we have SOHCAHTOA, okay, to determine the value of Z. So this is already an opposite. So we have your hypotenuse. So we'll be using the so that will be sine of theta is equal to your opposite, which is your Z, divided by your hypotenuse, which is your MBO. Now to get the value of your Z, so we have MBO, that will be times the sine of theta. Now substituting this value to the equation, okay, so from here, so continuing this equation, substituting in value, so we have the value of buoyant force, which is your specific weight times the volume displaced, okay, then multiply by the value of Z, which is MBO times the sine of theta. Then so this is the moment, which is your distance, which is equal now to the force, or let's say not our force, but already the value of the force, which is the specific weight, okay, times the new volume, so ito yun, then multiply by the S value, so the distance, so distance na yun. Now to get the value of the MBO, so this one, to get the value of your nito, so we can transpose yung ibang ano. So we have now rewriting our equation here, MBO. So MBO is equal now to the volume, specific weight times the volume times S, which is divided by your specific weight, no, times the volume displaced, then times your sine of theta here. Then we can cancel out your specific weight, so they are the same. So your MBO is equal now to so our MBO is equal now to the V, or the volume, times the S, then it is divided by the volume displaced, no? So that will be VD, sorry, so it will be VD times the sine of theta. Let's box that one. So we have the value, to get the value of your MBO. So we have the equation, which is your volume of this one, of the wedge, divided by the volume displaced, BD. Then we have the multiplied by the sine of theta. Usually, the volume displaced that is being displaced by the, so that is almost the volume of the natin ng ship, so which is being displaced. So that is yung part na ito. So the part that one, it is originally, okay, so being this volume being displaced originally, no? So this one, this part, okay. So this is the volume of the ship, which is already being which displaces the volume of water. Now the initial value of your MBO, okay, so consider this figure, no? Okay, so considering this figure, so we have a rectangular body that is immersed in a fluid. Then we have the corresponding length of the object, parallelly piped, and you have your length here. And we have here initially the displaced fluid, which is initially when there is no wave, we have your D, and we have the displacement of wedge dito. So if it is acted by a wave, so it is being the volume is being displaced, and we have the corresponding wedge which is already lumubog at this part, submerged at this part. Okay. Then we have the corresponding Methyl center, and you have your theta. Now taking the wedge, okay, so ito yung side na ito. So I'm going to resize that one. So we have here. Now it is in the form of a right triangle. Meron tayong right triangle dito. Then we have the corresponding theta here. And the length nito, okay, so as you observe here, okay, that is almost half length ng B. So this will be sized as B over 2. Okay. And the value at this side, so bringing down yung SOHCAHTOA. So we have your theta here. This is 90 degrees. So we have the sides, okay, given. Then we have the opposite, so we're going to use tangent. So tangent of theta, which is equal to your opposite. So let's say, let's give this a value. So this, just name it, call it x prime. Okay. So we have your x prime divided by the adjacent, which is your b of 2. Now the value of your x prime is equal now to b over 2 times the tangent of theta. Okay. Now to determine the volume of the wedge, your b, so ito yun. Then usually this is a triangle, so usually the equation of triangle is 1/2 base times your height. So you have your base times the height. Okay, then you multiply by the length, no? Now volume natin, that will be 1/2, no? Then the base, we have your b, so 2. Okay, then the height, usually that is the x prime, that will be b, so 2, b divided by 2 times, so I'm going to change this one. I'm going to change this one to a bracket. So this will be b sub 2, so that will be times the tangent of theta. Okay. Then we have the length here. Okay. So we have the volume to get the volume of the side, the volume of the wedge. Now simplifying our equation here, so you can simplify. This will become now your, so this is 2 times 2, that will be 4. Then we have your times 2, that will be 1/8. Then we have your b, so I'm going to b squared this one, b squared. Then we have the times the tangent of theta. Okay, then the times multiplied by the length. So we can rearrange our equation here, that it will be 1 divided by 8, so multiply by L times your b squared, then times the tangent of theta. Now for the small values of theta, the angle where your s is almost equal to 2/3 of the value of your b. Knowing that from our previous equation, so we have your MB0, so your MBO, so that is equal to the B times your S. So it is being divided by the volume displaced times your sine of theta. Then we're going to substitute the volume here and also the value of your S here. So we have the MV sub O is equal to your volume, which is your 1 divided by your 8 times the L times your B squared, no? Then times the tangent of theta, then multiply here with 2/3 of B. Okay. And it is being divided by the volume displaced dito. So the volume displaced, we have your BD divided by the sine of theta. Now for the small values of theta, so usually pag mainit yan, maliit yan, if you're going to use, as let's say, in theta mo, that is 0 point something or 0.000. So the sine of theta and tangent of theta are almost equal. So we're going to cancel that one. So if that happens, we're going to cancel that one. So if they are almost equal. So if they are almost equal, so we're going to cross out on natin na yan. Then our equation will be rewritten as your MV sub O. So that will be equal to, multiply mo yung 1/8 times 3 ay 1/8 times your 2/3. So we're going to multiply the 1/8 by 2/3, so it will be equal to 1. The 1/12. 1/12. So we have the L here, L dq. Then it is being divided by the volume displaced, bt. Okay. But the value of your 1/12 L times the B cube, so that will be the moment of inertia of the water line of the section. So we can rewrite our equation, which is your MBO. So that will be equal to the moment of inertia. So that will be divided by the volume of displaced. Let's box this equation. So this is, we have our equation for the length of invisible. So this is, so take note, this is formula can be applied to any section. So I'm going to write that one. It can be applied to any section of, let's say, kung ano yung magiging itsura ng hull, ng shape mo, o ng boat mo. Is either maging square ba or triangle siya, just only to make sure that the moment of inertia of that object is being taken and also divided by the volume displaced. Okay. So take note, since the metacentric height mg is dependent with the MVO, so the stability of the floating body therefore depends on the moment of inertia of the waterline section. Okay, so it depends. Okay, so it can also be seen that the body is more stable in pitching than in rolling. Okay, rolling, because the moment of inertia in pitching is greater, okay, than that in rolling. So you will notice, class, no, so if when you sinasabi yung pitching, so that is if we have a shift natin dito, ito yung bato natin. So usually yung sinasabi na yun explain dyan as rolling. So if we have here the axis ng so we have in the top view ng shift natin. So usually the rolling is yung ganon, we have the rolling, twisting on that one, the other side. So that is rolling vice versa. Now when we say pitching, okay, so that is yung the movement of the boat from swinging like this. So if you're going to draw this one, if you're going to draw the rolling, so usually if this is our ship, okay, in the bodies of water, so rolling is pag ganon, no? If this is the section of the ship, so in the bodies of water, so pag ganon, then ganon. So and while the pitching naman, that is, this is the front view. For example, this is the front view, no? The side, on the side view naman ng ship, which is yung tinatawag na pitching. Okay, so that is pag ganon. Then also pabalik. Okay, so that is pitching up and down, no? So sinasabi we have from here we can conclude that pitching is more stable compared to rolling. So you will see that the section of the pitching or the section area of the pitching is mas malaki compared to the section of area that is being covered by the rolling. Okay, so one way of also testing so I will attach here a picture. So one way of to determine the buoyancy of the ship is by launching it in here in a steel plate, then toss it in the water. Then it's supposed to be ang mangyayari is dapat makabalik yung ship. Okay, so if you will be you're already putting a tilt in this side, so eventually you have your overturning buoyant force here para bumalik siya sa another side, on the other side of the position. So you have your buoyant force moment here acting to push the part of the ship on the wedge side para bumalik siya sa dating yung original position. So that is one way of launching up. So I will attach the video on this one, so you can check that one also for better understanding of the stability. So maganda siyang panoorin. It's very napagandang eksena. So that is one way of doing testing, no? So the moment or the righting or the overturning moment on a floating body is equal to, that will be your RM or righting moment, or say the OM, no? So which is equal now to the weight times the X, okay? Which is equal now where your weight, no? Going back to the figure, so looking at the figure here, we have your weight here, then we have your OM, so overturning moment, and we have the other one is the RM, which is the righting moment. Okay, so that will be the weight, no, times the X, the displacement, no? And the same also here, we have your X also here. Okay, so the value of your X, you will notice there class kanina, so there is a form of triangle doon, so that will be the line. So we have the line MG going back, so we have the line MG, ito yun, so that will be MG, so we have your X dito. Then there's also the same here, we have the line MG from metacenter to the gravity, and then we have your theta to get the value of here, which is the opposite. So this is our X. Okay, so remembering from your SOHCAHTOA, so this is your theta, which is your opposite, no? And we have the line MG, which is your hypotenuse, so opposite, so we have your sine of theta, which is your opposite, is your X. Then we have your hypotenuse, which is your MG. Okay. So from there we have the value mx, which is the sine of theta times the mg, line mg, or the length mg. So substituting that one in our equation, so we have now the righting moment or overturning moment is equal now to the weight, then times the line mg times the sine of theta. Okay, so let's box the equation here. Now for the rectangular section, so again I draw here our rectangular section of body that is immersed in a fluid, liquid. So we have it is in a form of action of being tilted already, so we have the corresponding theta that is being angled here. Then we have also your S, so that is the space between the two force that is acting on the volume. So we have force acting going down, then we have the reactive force that is going up here, and we have also the new location of your buoyant force. So from this of O going to this one, where it is in the line of the action of your aligned to the meta center. Okay. Now we have also the given of the size of the block, which is the letter B. So how much is the length niya. Then we have also the depth or the draft, that is yung how much yung nakalubog sa tubig. So we have a given value, which is letter D. Now taking the portion, we have here a right triangle here. So zooming on this one, which is already being submerged in a liquid. Okay, so zooming on that one, so we have here taking the right triangle, you will notice that one. So we have also here the center of the gravity, where the location of the force that is where sa nagre-reactive force natin dito sa figure. So then we have the corresponding length ng side na to, which is that will be B divided by 2, since it is half ng ng section. Now to get the value of this side, so this is already opposites, and we have here the given B, so 2. So if you're going to look at the trigonometry, so we have the going back, so katuwa. So we have your adjacent value, and we need to find the opposite here. So that will be TOA, so that will be tangent of theta. So we have your opposite. So let's say let's blank this one. Let's say this is only let's give this name as asterage. So we have your asterage here divided by so that will be, so your adjacent, so we have your B over 2. So if you're going to rewrite the equation, that will be your asterage here, so is equal now your tangent, tangent of theta times B over 2. So that will be the value ng side na ito. Then for the hypotenuse, so we have here, so that will be your adjacent, and we have now sine, that will be sine of theta. So your opposite, so we have your opposite, which is tangent. So hypotenuse, okay, so we have your opposite, which is equal to tangent of theta, which is B over 2. Then it is divided by our hypotenuse value. It will be 8 hypotenuse. So I'm going to name that one. Let's say slash. Okay. So I'm going to put here a slash. That will be tangent of theta, which is B over 2. That is divided by the sine of theta. And if you're going to expand this one, so we have your tangent of theta. So usually tangent of theta is equal to sine of theta. So that will be sine of theta divided by the cosine of theta. Then this is times your B, so 2, and divided by the sine of theta. So you will notice here we have the cancellations here. Then we cancel out the sine of theta here. So we cancel out, so your slash now is equal to that will be B over 2 divided by the cosine of theta. Now from our trigonometric identities, from the trigonometric identities, so we have the cosine of theta, which is equal to 1 over the secant of theta. Now then transferring that one, so we have the secant of theta, which is equal to 1 over the cosine of theta. So substituting that one here, so we have the value of your slash, which is equal to the secant of theta, so that will be multiply b over 2. So that will be the value of your hypotenuse here. So this is now secant of theta times b over 2. And on this side, so we have the value of this one. Okay. Now from the equation, which is yung kanina we're doing, we have your equation for the m v sub o, which is equal to the bs, then it is divided by the volume displacement times the sine of theta, where our volume displacement is equal to the b, so this one b, times the d, then times the l, which is the L natin doon. So going back here at this side, so B, D, which is the depth and the width and the length. Okay, so we have the volume displaced ng body. And where also our B, going back here, we have the value here of P, which is L, D squared, tangent of theta, that is 1/8. Okay, so that is the value of your B, value of your B. So then you have your S. So the centroid of the triangle, which is your x bar. Now from the geometry, the x bar, which is equal now to the x of 1 plus the x of 2 plus the x of 3, which is divided by 3, no? Where our x bar is equal to x of 1, that will be 0, so the perimeter, then plus the value, we have your b over 2, so that will be multiplied by secant of theta, then plus the b over 2, so that is multiplied by the cosine of theta, so referring to the figure here. Okay. So we have the cosine of theta, then it is being divided by again by 3, so substituting lang yung value natin doon, so we have divided by 3. Now then we're going to factor out yung common dito sa ibabaw, so we have your x bar here, so that will be b2. Then it will be factor out, we have your secant theta, then plus cosine of theta, then it is divided by 3. So let's combine this one, so we have here the x of bar, that will be b over 2, then this will become reverse that one, so we have multiplied it by 1 over 3, then we have, so the value, the secant theta, again looking back the trigonometric identities, so we have secant theta is equal to 1 over cosine theta, so we have here 1 over cosine of theta plus the cosine of theta. So this will become your x bar is equal to b over 6 times the 1 plus the cosine of theta plus cosine of theta. Now taking the denominator here, your x, your cosine, so we have the b over 6. Okay. So taking the denominator, which is your cosine of theta, so that will be cosine of theta divided by cosine of theta, that will be 1 times 1, so we have 1 here, then this will become the cosine of theta squared, so this is 1 times 1 of the cosine squared theta, so this is cosine theta here. And the value of your x bar from here, so the location of the center of the gravity, so that will be the s, no? So that will be the s divided by 2. Okay, so that will be also equal to your x bar. Now substituting that one here, so we have the s, which is now equal to s divided by 2. So we can transpose that one here. So since it is equal, so we have the value of your s here. This is multiplied to this one. We have your 2b over 6, then multiply by 1 plus the cosine squared theta. Then it is being divided by the cosine of theta. So this will become now your that will be b over 3. So that will be 1 plus cosine squared theta divided by the cosine of theta here. Now substituting the value of s and also the bd, the value of the bd, where the value of bd, we have bdl, and that will be multiplied by sine of theta. Okay. So substituting our value here, so we have your mu, where your b, so the value of the b, that will be 1/8 times the length b squared times tangent of theta. So close parenthesis this one, then multiply it by the value of your s. Okay. So multiply by the value of s, so we have this one. Okay, then it is divided by BDL. So it will be BDL, then times the sine of theta. Now we're going to distribute this one, so we have now m mu, so that will be equal to, so that will be equal to that, so this is L, so we have L here, L, then multiply this one, we have here b cubed dito, then 8 times 3, so that is over 24, no? Then we have tangent of theta. So tangent of theta can be expressed as sine of theta divided by the cosine of theta. Then it will be multiplied to the 1 plus cosine squared theta divided by the cosine of theta. Then divided by this one by b dl times the sine of theta. So let's try to analyze this one. So we have here the common, so we have the sine of theta, so it will be cancelled out. So this is already cancelled out, cancel na ito. Okay, so what is left is ito na lang. So sa ibaba we have L b cube divided by, so we have the also to cancel out in b cube, so that we move also. So this one will be, so this is b and will be removed. So may 1 ulit po, dalawa. We have also d, we have your L will be cancelled out. This one will cancel out, so I'm going to erase now this one. So may 1 na lang is squared, so we have squared here, then we have 24, so we have 1 plus cosine squared, then cosine of theta, so pasok natin doon sa equation. Here, distribute that one. So we have 1 plus cosine squared theta divided by the cosine squared theta. Now our equation here will become, so we have b squared over 24. Okay, so cancelled out in cosine squared here, so will be maiwan na lang is 1 over cosine squared theta, so this one, and plus 1, so this is will be cancelled out. Noting that our cosine squared, no, so going back to trigonometric identities natin, so our cosine squared or cosine, it will be 1 over the second, so it is equal to second theta over 1 over cosine, so this will can become b squared over 24. Then this will become the second squared theta plus 1. Now from the trigonometric identities, so we call it the Pythagorean relationship. Now from the Pythagorean relations, so we have the value of the second squared theta. So the second squared theta is equal to 1 plus the tangent squared theta. Then substituting this value to the equation here, so we have the m b sub o, so it will become now b squared times 24. Then substituting yung value ng second squared theta, so we have 1 plus the tangent squared theta, then plus 1. So this will become also the same value. We're going to add that one. So let's try to factor this one. So we can be b squared over, this will become 12, no, times 2. So they are the same. Okay. Then multiply by the value of d. Okay. So we forgot to add the d here. So meron pa pala tayong d dito. Kalimutan natin. So we forgot to add the d here. And the d dito, so doing that, so adding that one, so we have here the d, okay, inserting that one. So we have here, we have the tangent, no? Tangent squared theta plus 2. So if we try to distribute the value of 2 inside, so we can do that by means of, so m is o, we have b squared over 12d, okay. Then multiply natin doon sa loob, so we have the value here, so we have the value here of tangent squared theta, so distribute natin ng 2 dito, and then we have the 2 here plus 2 over 2. So finally, we can rewrite our equation as MBO. So that will be b squared divided by 12d times tangent squared theta divided by 2 plus 1. So we have the modified equation for the value of MBO.